June 4th, 2015. Guys, this information is very important, and it just came out 2 days ago, and it may have a lot to do with some of the events that we're seeing at CERN, and since it's newly discovered, they may not know exactly what they've been dealing with, but we know that they've been having high-speed collisions, and they're looking into different dimensions, or dealing with plasma. So this may tie in very well into either their plans or the effects. Again, they may not have known because it's new information from these astronomers. Now, this article, and I will link to it in the video, is that astronomers confirm that giant plasma tubes are floating above the Earth. Now, it's interesting because they surround our magnetic lines of force that go out and they create our magnetosphere, which are our Earth shields. And we know that they're induced ground currents that are affected by these magnetic lines of force as they come into our Earth from the north and exit the south. Again, magnetic north and south. And you've seen enough of my videos, you know what I'm talking about there. But astronomers have for the first time captured visual evidence of the existence of tubular plasma structures in the inner layers of the magnetosphere surrounding the Earth. For over 60 years, scientists have believed that these structures existed, but by imaging them for the first time, they provided visual evidence they are really there. Now, this is coming from the School of Physics at the University of Sydney in Australia. And the astronomer's name is Cleo Loy, and she's got an excellent video. I'm going to link to that. Now, obviously, she's thinking out of the box, and that's really what the best scientists come from, just like when we talk about the sun causing the earthquakes. But she's the lead author in this research done as part of her award-winning undergraduate thesis and published in the Journal of Geophysical Research Letters. Now, they're going to say that the region of space around the Earth occupied by its magnetic field, called the magnetosphere, we've watched it many times, is filled with plasma created by the atmosphere being ionized by sunlight. The innermost layer of the magnetosphere is the ionosphere, and above that is the plasmasphere. They are embedded with a variety of strangely shaped plasma structures, including the tubes. We measured their position to be 600 kilometers above the ground in the upper ionosphere, and they appear to be continuing upwards into the plasmasphere. And guys, you're talking about a direct feed, and then again, how will this apply to the science of CERN? It's definitely worth the research to find out. It says this is around where the neutral atmosphere ends, and we are transitioning to the plasma of outer space. So there's a direct connection there, and when you do that, again, we've talked about the Earth's and the Sun's magnetic connectivity point. Now you're dealing with plasma connections from outer space into the, again, the magnetosphere of the Earth transferred into the ionosphere. A whole new science will develop around this, and it may, again, be some of the reasons we're seeing the effects of CERN on the magnetosphere and on possibly even on the uptick in magnetic activity as far as the filaments on our sun. But they're using a ground array of systems called the Murchison Wide Field Array. It's a radio telescope in the western Australian desert. Loy found that she could map large patches of the sky and exploit the array's rapid snapshot capabilities to create a movie, effectively capturing the real-time movement of the plasma. She has been awarded the 2015 Bach Prize of the Astronomical Society of Australia. Like I said, that's how you think out of the box. That's great, and her video is definitely worth the time to watch. Guys, there in this array that they're using, you'll see they're using left side and right side arrays fed into computers, but maintaining the separate inputs, and so that gives them, just like you have left and right vision combined, gives you stereo vision, so they're getting 3D images, and that's also in the video. But guys, let's take a look at CERN. As you can see, they've been running hard all day. Now, the last section is the highest energy we see from 1200 hours, because you see the red and blue beams of beam 1 in blue and beam red in 2. And here you also see large spikes. Now the black lines is the beam energy, the blue and red are being called beam intensity. Remember in yesterday's video, we started seeing points where they were reaching luminosity at these high-speed collisions, and that's again key to, I think, this plasma link with these plasma tubes. Now, I also notice a difference in this chart. They're running at 6.50 TeV per beam, gives them the 13 TeV collision points. In the left, you see the energy in this chart is green instead of black. Your red and blue indicates beam 1 and beam 2. You can see the multiple injections as they're trying to run it. Again, remember they're going to try to achieve 2,800 collisions per second. Now, one thing in this chart is that they're starting to level off. They're maybe getting better control of this emittance. And notice also luminosity is again being achieved as they ramped up right here. That is something in itself is tied in with, going to end up being tied in with the plasma. But again, they have said this is the year of luminosity. We know how that works. But also tune back, you can see as they cranked up. And let's take a look at the beam. Again, these are live as of 5:44 p.m. Central Daylight Time. Beam 1 on the left, beam 2 in the right. You can see that they're running at high speed because it's called squeezing. The faster the speed, the tighter they become. Slower speeds, you start seeing the larger dots. Now I want to switch to the ACE satellite chart because I believe they're directly related. Again, notice that this activity, definite uptick from the normal charts, guys. When you're seeing these spikes like that, that's usually a large solar flare, coronal mass ejection, and we've seen those on the uptick in the last few days. But that activity that we saw yesterday has continued. Also, let's take a look at the Solar Dynamics Observatory. Today has been quiet as far as CME releases, but the sunspot on the top left we talked about yesterday has increased the chance of flares, and we're starting to see an uptick in that also. Now, we need to also keep an eye on the magnetopause. Guys, these links are on our website. I'm going to go through. You see from the 3rd up until today. Look at that. See an area of smoothness, then those collapses. That's extreme pressure, and I knew it when we saw the ACE satellite images that was going to build. That is the shields of our planet, the magnetosphere. The magnetopause is that end point. We'll go into the current and the latest images and check the compression. I'm just moving it up. Notice your timestamp at the top left. Those compression events continue. Look at that. Very large expansion. If you think about when something's compressed very tightly and released, there will be expansion. But these are very unusual images, just like the ones crossing ACE. And the ACE satellites are placed between the Earth and the Sun as an early warning system. Now, this is the last few frames of today. Again, now we're at 5:06 p.m. Central Daylight Time. We're going to go through the last few here, and you can see that we're compressed very tightly. The white ring you see is where the satellites listed in the right-hand column, 15, 14, and 13, and the South Korean satellite are at. So our shields are being compressed into our satellite bands. That's a lot. It's a heads up, guys. We need to watch this. Again, we're talking about new science and almost all the things we mentioned in this video. Heads up, be safe.